Welcome to Utilizing Tech, the podcast about emerging technology from Gestalt IT. This season of Utilizing Tech focuses on CXL, a new technology that promises to revolutionize enterprise computing. I'm your host, Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. Joining me today as my co-host is Craig Rodgers.
Hi, I'm Craig Rodgers. You can find me on Twitter at CraigRodgersMS.
So, Craig, you and I are really focused on the practical applications of technology, although it's fun to dream about what might happen in the future and what might come and how things might be revolutionized. It's much more interesting, I think, to stick to the nuts and bolts of how things really do work. And with CXL, that's been a little bit of a challenge since we didn't really have a platform that supported it until now. AMD recently announced their next generation Epyc server CPU line, codenamed Genoa, and it supports CXL. It includes CXL. Can I get a yay from you, Craig?
Absolutely, yay! It's a mammoth release. Server, up to 96 cores. It is just unbelievable. Going back to my VDI days, you could have dreamed of those number of cores and a CPU. It's exciting. Yeah, it's exciting.
Yep. Yeah, and not only that, of course, but we've got, if I recall correctly, I think 12 channels of DDR5 memory. We've got PCI Express 5, and yes, we've got CXL. So exactly. So this is exciting. We're excited. We're so excited that we decided to invite on as our guest this week Mahesh Wag from AMD, who knows a thing or two about this platform and also about CXL generally. Mahesh, welcome to the show.
Hey guys, nice to be here.
So give us a little background. Who are you? What's your position relative to CXL?
Yep, my name is Mahesh Wag. I'm a senior fellow at AMD, and I'm responsible for the server system architecture. Within that, I'm specifically focusing on enabling on our execution plans for CXL, and we're very happy to bring a breakthrough memory expansion with CXL. And in addition to my role at AMD, I'm also within the CXL Consortium, co-chair of the board's technical task force, so that looks at the definition of the future generation for CXL.
It must be great being on the board there as well, getting to work on the actual specifications. Obviously in your role in AMD, Genoa has come out, but you obviously have more advanced products that you're working on, and they need to marry up in terms of CXL specification to that which has been released by the consortium. So it must be great to be able to see both sides of that table.
Yeah, and just a little bit of background there. I was co-chairing the protocol work group through the first two generations of CXL. So, this has been, I'm familiar with this for many years, and it's great to see the products out. So, would be really happy to talk about all the features that we have, the capabilities, and what are the solutions we can bring to market. I guess the key takeaway I want the listeners to take out of that is, you don't have to wait for anything. CXL is here. CXL 1.1, you can enable a lot of memory expansion solutions with that, and we can talk all about it.
Kudos to AMD on being first to market with a viable platform for CXL devices. Now we will actually be able to do memory pooling, which sounds as though has been a requirement that a lot of the industry has wanted for a long time.
Yep, and I think pooling is great, but even if we get before pooling, I think we should talk about all the things that we need to do that's in front of us to bring CXL to the market. And the first thing, and I keep telling my team and our customers, our partners, is we got to prove CXL is functional and performant. And for that, you need a good set of features that we need to go enable with the ecosystem, in the market, right? And that's what we're focusing on. Right? So if you think about pooling and memory expansion in general, from a systems perspective, there are many things that you need to really consider. And we can talk about what those areas are, what those features are, right? What we are bringing with our fourth generation AMD Epyc product is this breakthrough memory expansion, right? And when I think about breakthrough memory expansion, a few things come to mind. One is you got to provide the system flexibility, right? In terms of, what are the solutions that are going to be out there? Is it capacity? Is it bandwidth? Is it both, right? What is it that you're targeting? There's the expansion part of it, which is you got to make sure that it's performant. So there's a lot of work that really happens both on the CPU side as well as with the memory controller vendors on improving that performance. You need to address security. And the other key thing that we're bringing along with in this first generation is really this notion of a tiered memory system, right? With CXL, as you know, we introduce it as a headless NUMA node, and memory appears as a tiered memory solution. And we are really focusing on making sure that we bring a very performant tiered memory solution to the market. And then once you establish that, what that leads to is more disaggregated memory with pooling. And then one of the additional things, right? There's this one more thing. We can also enable persistent memory with CXL.
Indeed, it'll be nice to get Optane level functionality there through the CXL bus. It'd be very good. It filled a great sweet spot in terms of performance and latency. It's very good. The memory expansion cards, we've spoke to manufacturers of these cards, and some of them have some really interesting benchmarks in terms of throughput and the level of performance that they're able to attain through CXL. Some were even quoting numbers in the mid-90s in terms of percentage throughput. What have your observations been? You have obviously had to done a lot of interoperability testing and product design work there.
Yeah, so one of the things, right, I mean, we spend more than about 30, 40 hours a week with the controller vendors and optimizing for the memory performance, right? Now, always when you talk about this benchmark, it starts with, what are you benchmarking against and what's a good metric for CXL attached memory? And in the first generation, we were just saying you got to be better than equal to what you can achieve with the remote socket latency. So for example, if I consider it to be the same memory channel, I'm expecting the performance for a CXL attached device for that same media, right? So if you kind of keep the media, let's say DDR5, a single channel, we expect the performance to achieve similar to what we would if that channel was on a remote socket, right? So that sort of gives a guideline for what we could do with our memory controllers, and we're expecting the same when we're working with the ASIC vendors that are bringing the solutions to the market. So that gives a guideline for we want that performance to be as good or equal to what we see with remote socket memory, and the results are looking pretty good, right? We're working with some of the very first engineering samples. We work very closely on tuning their microarchitecture, their knobs for performance, and we're starting to get pretty good latency bandwidth curves. So we're focusing on that latency bandwidth curve and making it look and behave as good as what we would see with a remote socket latency.
Yeah, one of the things you mentioned there, I wanted to kind of help our listeners to sort of follow along. So, for a long time, we've had this concept of NUMA, non-uniform memory, in multi-processor servers, and the idea there is that each processor has its own resources, including memory, and that the processors are able to communicate with each other and with each other's resources in a way that is not necessarily uniform. In other words, my memory is different from your memory, but I can still access yours. And the system, including the software on top of that, is able to adapt when I do those things, when I access resources that are non uniform. What you're describing is that CXL based memory will also be part of this legacy of non-uniform memory access, in that I can access memory that's not just your memory, but that's memory that's the CXL memory. It's headless. It's not another processor. It just is on a different channel. And what I'm hearing you say is that your goal would be that CXL-based memory would be roughly similar in terms of latency and performance to memory that would be owned by another socket. Is that right?
Yeah, it'll be, the goal is to get it to one NUMA hop away, right? That's the way to look at it, right? And then the other thing that I was talking about it is once we understand that and we can do the latency bandwidth plot, right, for that NUMA hop latency, you can figure out, where your tail latencies are, what your latency bandwidth profile is. And once you understand that, then you can decide when and how to map your applications onto which NUMA node, right? And then there are many different policies in which case, how we're seeing our customers deploy their applications, right? There are many different ways people are approaching for how they're going to solve their problems.
And that is going to require software, right? Scheduling software. That's not something that's going to happen within the CPU complex.
Right, that's right. And there's a lot of developments that are happening. So now we're getting into this concept of tiered memory and how do you manage this tiered memory, right? And you touched on one aspect of it, which is really important. That NUMA-ness, or the concept of NUMA isn't new, right? It's been there. It's been within the industry for quite some time. People really understand that very well. What has been there is you got a NUMA node with processors and memory sort of in a NUMA domain, and then you understand how what your access is going to be as you reach across the NUMA domains. With CXL, we're bringing this concept of headless NUMA node, which is now you have a NUMA domain, but you don't have cores associated with it, right? And it's available. Uh, the definition through the CXL specification now provides you a way to describe the NUMA properties. So you can say what your distance is, your proximity is, right? So based on that, now you know what it means for access latencies to this particular NUMA node. So that's first. Then in terms of the software, tiering software, there are many different ways you can look at it. Some applications would look at, if you don't do anything, the typical, policies are you allocate out of your direct attach memory, and then when you run out of it, you start allocating out of CXL attach memory or this NUMA node, right? So that's one way of deploying it. There are other ways which are more dynamically looking at what your access patterns are, and then determining how you're going to allocate out of, your DRAM or CXL attach memory. And there are, one good example of that would be the work that Meta has done with, transparent page promotion, right? Which is basically you can manage the hot and cold tiers, look at where the applications are, and targeting, and then based on that, you know, demote or promote memory from your, hot tier to your warm tier, right? And that part of code is already upstreamed, right? So there's a lot of development that is happening in the ecosystem to bring tiered memory to the market.
And somebody who goes out there and buys themselves a fourth generation Epic server and one of the actually quite a few memory expansion CXL memory expansion devices that are coming to market, will they need to buy a piece of software, or will they be able to maybe use a driver or even something built into the Linux kernel and just sort of use it?
Yeah, I think that's the great thing about CXL is a couple of things, right? What you talked about, even if we just stretch it a little bit, right? If somebody brings a system, can they just plug in a card and expect it to work? And the answer is yes, right? Our BIOS support is in there to bring that device all the way up to NUMA node. And if you didn't do anything, the way we enable it is that you just show up as a NUMA node and we map it as general purpose memory, in which case that memory is available to OS to use as is right off the bat, off the package, right? Now, the additional hardware capabilities that CXL brings in is you don't have to a priori configure the port to be either PCI Express or CXL, right? You can plug in a card, and we detect, right around the bring up whether it's PCI Express or CXL. If it's PCI Express, we'll function in a PCI Express mode. If it's CXL, we'll discover the card capabilities, map it as system memory, and then hand it over to the OS. If we map it as our default mapping is general purpose memory, so OS can start making use of it. Now, for certain special applications, we provide the ability to map it as reserved memory, in which case, it'll show up as memory mapped, but as reserved memory. And then it depends on the kernel memory manager how to make use of that particular memory.
Interesting. And of course, the CXL spec includes more than that, as you mentioned, different memory technologies, hierarchical memory, but also shared and pooled memory. Is that supported by the fourth generation Epic platform?
So a couple of things there, right? I think part of it is, maybe I would touch on just the media part of it, right? By definition, CXL is media agnostic, right? So you can start with any particular media that you want behind it. It could be DDR4, DDR5, LPDDR, and any new memories, right? Storage class memory. So the first thing CXL does is it abstracts that out. What we are going to see is the very first few generations of, the early adopters are going to be DDR4, DDR5. There is, if you were at Flash Memory Summit, you saw all the excitement around using NVMe. So we're seeing a lot of traction in that space. Now, coming to what can you do in terms of pooling and sharing, right? There are two ways, there are two ways you can enable pooling and sharing. One is using, switches and then enabling a pooled solution. And the other one is really this direct attached, multi-headed controllers, right? So for example, if you think about, let's take an example, a DDR5 memory controller that has more than one CXL port coming out of it. And there are some vendors out there who have these solutions today, right? So you can enable a pool solution with the 4th gen AMD Epyc, where from one socket you have a link going to that controller, from another socket or from another host you have a link going to that same controller, and then the resources that you have on the controller, you can pool them across the two nodes. Now when it comes to, the definition of pooling is really, you carve out a certain partition and you assign it to a given host. That partition is not available to the other host. The definition of sharing is you're accessing the same physical address. Um, Certainly, sharing can be enabled even with 4th gen AMD Epyc, but that sharing part would require some amount of software, because we don't provide hardware consistency in that case, and you require software-based consistency rules for managing that particular memory. But as long as you could do it through software, then yes, certainly those sharing models for that type of device are possible. And we're seeing a lot of interest in proof of concepts and work being done with several vendors with our 4th gen and AMD Epic on both pooling as well as sharing.
And also, just to kind of get this out of the way as well, in terms of numbers, which version of CXL and PCI Express is included in the platform?
So we support PCI Express Gen 5, right? So we can run at the Gen 5 data rate, providing the massive bandwidth. And we support CXL 1.1 plus some additional features that are there in CXL 1.1. And basically, we've looked at it. The way to think about it is, if there is a CXL 2.0 device, right, you should be able to plug that device in an AMD Epic platform, and the device, by definition, is required to be 1.1 compatible. So you can have the link operate at 1.1, but we can take advantage of some of the CXL 2.0 features that are defined. Right? That way we can enable. So for example, the driver that would run in the kernel or the OS would be a CXL 2.0 ready driver that can work with with these devices. So we're sort of forward looking from that perspective, as we pulled in some key features that were defined in the CXL 2.0 spec and enabled them on the 1.1.
Can you elaborate on which of those specific features you mean?
Yeah, a couple of features. For example, if one good example of that would be global persistence flush. This is required if you're supporting persistent memory. Then we provide the ability to do, on a power fail notification, send, that notification event to the device. So if it's a device that implements persistent memory, it can flush the contents to its, persistency. And it requires some coordination on the CPU side for flushing all the, caches, because it's a global event. So we already have that support built into the 4th gen AMD Epic. So we can support persistent memory right off the bat. So that's one example. Another good example is the definition of firmware first, right? So firmware first error handling was defined in CXL 2.0. We pulled in that ability to do the firmware first error handling in our 4th gen AMD Epic. So we pulled in those capabilities. And finally, the one we talked about, the device could be CXL 2.0. It advertises all the capabilities. So from a software perspective, the discovery mechanism is that it can discover all the CXL 2.0 capabilities that are device specific, and then we can support them on our platform because they don't have host implications.
It's going to be exciting to see how software companies leverage these new capabilities and new features that they haven't had access to before. I think it's really going to help with adoption of CXL. You know, some think hypervisors. You know, hypervisors taking advantage of CXL. Linux, you know, opens up huge doors. You know, there's a lot of native support baked into the kernel already. So there's going to be new workloads we've never even thought of here, or how they were going to be computed or arriving on the scene. The software vendors, I'm sure you have been working with a lot of them already, providing engineering samples to let them get a bit of a head start, because I'm sure you want workloads taking advantage of these new features as well.
That's right. And I think, it sort of goes into a couple of things right there. We're working with, several different software vendors who are looking at bringing, very effective tiered memory solutions. Right? This is where you're looking at, how do you manage tiered memory? We have some hardware hooks. We didn't talk about that, but when we think about bringing tiered memory solution, there's sort of two aspects of it if you're managing this tiered memory, right? One is you need to have a profiling driver that says, where is your residency of pages that you're accessing? Is it in, warm tier or hot tier? Right? So we provide certain capabilities from our CPU. It's called instruction-based sampling. Based on that, you can figure out and very quickly determine, the residency of those pages. A good example for that would be some of the work that a company called MemWorge has done. You can look at some of their presentations at Flash Memory Summit, OCP Summit, where they've shown an advantage of using, odd instruction-based sampling and get, significant performance improvements for their profiling driver. Now, in addition to that, then, so the profiling driver will tell you, okay, where the hot cold pages are. Then you have a policy engine that determines when it is appropriate to move the pages, right? And that's a kernel level policy decision. And when you actually have to do the data move, we provide hardware data mover engines that those that page moving piece of software can make use of direct hardware capabilities. So you're not making use of cores to move the data. So we provide all of these sort of hooks, the hardware hooks, for some of the software vendors that are looking at taking advantage of the hardware capabilities for bringing in a tiered memory solution. I think that's going to be very powerful.
Very much so. We've spoke with Memverge. We're familiar with the product and the capabilities. You know, they're a great example. You know, being able to snapshot a whole machine, memory and all, create a copy of it in another machine if that spot instance goes down. There's new functionality we never had before coming off the back of CXL, and Epic processors are going to deliver.
And there are a lot of software development kits also available, right? So for example, you have Samsung with the SMDK. I think that's, as you're looking at your application performance tuning and you want to run some experiments, I think SMDK is a very good tool because it allows you to manage your memory and figure out the impact of different memory organizations. Either you're sort of interleaving or you have different tiering schemes on your application, so you can make use of that SMDK if you're doing some exploration. So we're seeing a lot of software development in this space. Significant amount of code is already available or already upstreamed in Linux, and we're seeing several of these companies take advantage of these capabilities, provide the tool set, and it's all in the general goodness of the ecosystem, right? Because you're enabling, as you're delivering these tools, you're enabling the ecosystem to sort of take advantage of the hardware, put certain systems together and start exploring what the impact of it is on their applications.
So as a company that works with basically every other company in the space, I think that it is important that you're working with multiple different software providers to make sure that the software and of course the hardware is all compatible. But I know that there are also that you're also working with the consortium itself to push this technology forward. I don't know if you want to take a moment and talk to us a little bit more about how the CXL Consortium is working with AMD and with other hardware and software vendors to push the technology forward.
Yeah, I mean, on the consortium side, right? I think what typically consortiums, either it's PCI SIG or other consortiums, don't go a whole lot into product level stuff, but they're more of the enabling um, sort of organizations, right? That enable products and things to do that. Now, I believe what the consortium is looking at is sometime early next year start putting together something along the lines of a developers conference where you can have people come in and share what their learnings have been so far and start working towards that. But up until now, the consortium has done a great job for the ecosystem enabling on providing training sessions, webinars, and things like that, where people can come in and talk about some of the challenges that they're seeing, what is being addressed to meet those challenges, right? So just to give you an example, I did a presentation with Meta on some of the memory challenges in one of the CXL webinars, right, where we came in and talked about when you look at from a memory expansion perspective, what are the challenges, what is the consortium doing in terms of the specification to address those challenges, what's happening in the ecosystem around those challenges, right? So there's a lot of work that and a thought that gets put behind every time there is a webinar, there's a discussion in the technical task force around what are the issues, problems people are saying, what is the material, what's the training that we need to put forward to enable that. So a lot of enabling happens from that perspective, and pretty much at each of the forums, if it's just to give some examples, FMS, OCP Summit, Supercomputing 22, there have been sessions, both from the consortium marketing work group as well as the technical experts to answer any questions on those topics, right? So that's what the consortium supports from bringing the ecosystem together. And then there's, of course, the compliance program that the consortium will be driving, which is to make sure you have a compliance test suite that's developed so that designs can bring in and run them through the compliance suite.
Where the consortium has really delivered very well is simply the sheer size and scale that they've been able to grow to in terms of members. Even competitors are on board and have all agreed to do it this way. That alone, outside of even creating the specifications, that alone on getting that many people around the same table was an achievement.
Yeah, no, I completely agree with that, right? I think if you look into just the size, and pretty much you got all of the compute vendors as part of the consortium. Pretty much everybody from the memory side part of the consortium, as well as the controller device vendors, right? So if you look into where the consortium is going, it's really a significant achievement in terms of pulling that big a ecosystem together, and then just bringing everybody together to address the questions, where does the technology need to go, what's the future, and things like that, right?
So Mahesh, obviously in the enterprise space, security is always a huge thing. Can you tell me what you have done to enable us to use CXL securely?
Yeah, from an AMD perspective, we have our technology called Infinity Guard, right? That provides security features for DRAM. And then, you might also know it as SEV, secure encrypted virtualization, right? And basically, it's providing, the capabilities for confidential compute. And one of the things that we're really proud about the way we enable that is the same capabilities and features that you have for protecting your content that's going to DDR memory, direct attached DDR, that seamlessly carries forward over CXL, because we do support all of that encryption on the host side. So whether if it's those accesses are going to DDR or if those accesses are going to CXL, we provide the same level of capability um, that you have on DDR. We extend it to CXL. And the good thing about that is that we don't need any specific device side support. So this mechanism just works seamlessly across all device vendors, because the bulk of that is, I mean, not bulk, all of it is done on the host side for providing that capability.
Nice to see that at being achieved at a hardware layer rather than software. The fact that it's baked in is great. I'm also excited around persistent memory storage coming in via the CXL bus. And have you done anything to enable, facilitate, speed up, secure? Have you done anything around that?
Yeah, our 4 gen AMD Epyc processors are capable of understanding and managing persistent memory from just the persistent memory domains perspective, right? So what we did in that was, as I was talking about before, we intercepted some of the features for persistent memory that were defined in CXL 2.0. We pulled that in CXL 1.1, and we're now seeing interest with persistent memory. Think about an NVMe device with CXL on with DRAM on the front end and then NVMe on the back, and then that particular device can operate as a persistent memory device. And we're working on enabling that solution with a couple of vendors. If you were at Supercomputing 22, you would see some demos where we already shown that functioning on a 4th-gen AMD Epyc with a Samsung NVMe drive that does persistency. So, we're starting to see that, pick up. There's a lot of interest in CXL plus NVMe. So, stay tuned for more news on that and more excitement in 23.
Yeah, I'm glad you brought that up because, of course, NVMe is also leveraging PCIe technology, as are lots and lots of other things. And there certainly is overlap between lots of the advancements that are happening for storage and I/O and networking and graphics and everything, not just for memory expansion. So we'll be very excited to see where this goes in the future. One final
Yep.
question I have for you is, I guess, sort of think visionary here for a moment. How might CXL change the way servers look in the future, and maybe even change the priorities of a company like AMD when designing future server processors?
Yeah, so we're looking at it, right? I think if you think about, there are two aspects of it, right? One is, we talked heavily today on just, what does memory expansion perspective, right? But we need to look into that from a server perspective. What does the roadmap start to look like for accelerators? And we're starting to see a significant amount of interest in the future right around CXL 3.0 with accelerators. So we do, we are expecting some accelerator uptake in that particular time frame with CXL 3.0, right? And that would change. If you think about how PCI devices are getting built, as you have these capabilities, we'll see a shift in more towards taking advantage of what the coherency can bring to certain devices, right? So that'll be an area to watch and see where that is heading. In terms of memory expansion, we're looking at it as we're adding more cores, right? And the memory bandwidth has to keep up to provide that both the capacity and bandwidth. And it continues to be an expensive sort of resource if you think about it from a server perspective. So we are going to see significant amount of memory hierarchy optimizations as we go through and look into the future. Now, what does that mean? One of their answers could be that we would start looking at what are the things we need to do on the CPU side to improve the efficiency or performance for that, right? So that's about I can say here, but we do expect to see both CXL continue to play as a tiered memory solution for a significant amount of the future. Can that be enhanced further? I think that's where all the explorations are.
Yeah. It is really going to be interesting to see where this goes, because I do suspect that if this technology really takes off the way many of us think it will change the priorities of system designers, especially of CPU designers, and we'll see what that means for the future of the processor market, the accelerator market, the XPU world, and frankly, a lot of the decisions that are being made around system design. Many of those may be challenged by CXL. So we'll see where this goes. I'm obviously pretty excited about it, but we'll see
Yeah,
what gets real.
yeah, and we're excited about it, and that journey is already started, and it just gets enhanced even more because now with the ASICs and the platforms out there, right? Really, it's all on the ecosystem to provide a performant CXL memory expansion solution, right? Because everything is based on how well we do in the next year in terms of proving that CXL is functional and performant, because that's a promise. Once we deliver that, everything else is going to ride on that. So
Yeah.
that's what we're focused on. That's what our customers and some of our ecosystem partners are focused on.
Yeah, and that's really where it all makes sense, and that's why we named this utilizing AI, now utilizing CXL, because as exciting as the technology is, it really matters more how it is made, how companies make use of it, how customers make use of it, and what it's able to do in the real world, not just what it theoretically might enable in the future. So we'll be definitely keeping an eye on this. I really want to catch up with you again, maybe later in the season, maybe next season of the podcast, and see what the reality is of these chips when they're out there on the market, when servers are out there, when people are making use of this technology. How can people continue the conversation with you in the meantime, Mahesh?
Yeah, I think a good way to reach out to me, would be just on LinkedIn. You should be able to find me on LinkedIn. If there's interest in the technology itself, then I would suggest going to computerexpresslink.org, and then get that connected there if you want to get connected with the consortium.
Great, thank you, and we'll include those links in the show notes. Craig, anything you want to pitch before we go?
You can find me on Twitter at Craig Rodgers MS. My blog is craigrodgers.co.uk, and I'm also available on LinkedIn.
And as for me, you'll find me at Foskett on most social media networks, including the new mastodons. Thank you for listening to Utilizing CXL, part of the Utilizing Tech podcast series. If you enjoyed this discussion, please do subscribe and give us a rating and a review in your favorite podcast application. We're pretty much available everywhere now. You can also find us on YouTube. Just go to YouTube/GestaltIT video. This podcast is brought to you by GestaltIT.com, your home for IT coverage from across the enterprise. For show notes and more episodes, go to utilizingtech.com or find us on Twitter at utilizingtech. Thanks for listening, and we'll see you next week.